Hello, it's the Azure Data Guy, and welcome to my series on analytics on Azure. Today we're going to be talking about storage. So, when it comes to cloud storage, there are usually numerous options, and they can get confusing. So we're going to go over the options that you need to know when determining what kind of storage to use and when to use it. So, the first option is storage type. In Azure, we have multiple different choices. So there's blob storage, there's file storage, and then there's HDFS compliant storage. There's actually more than that, but for this course, we want to keep things simple. Also, if you're not aware of what HDFS is, it stands for Hadoop Distributed File System, and it's a way of storing large amounts of data in a distributed fashion across many nodes. We'll talk more on HDFS later, but it's very important when it comes to big data clusters. Blob storage on Azure is for storing objects such as images, videos, flat files, and so forth. Typically, blob storage is much cheaper than storing files inside of a virtual disk of a virtual machine. But also, you can typically only access blob storage programmatically. So with blob storage, you only pay for the amount consumed, not the amount provisioned like a disk in a VM. But do note there are charges for reading and writing to blob storage, which in most cases is trivial, but at massive scale they can add up. If you find yourself in a scenario where you're writing tens of thousands of times per second, say in an IoT use case, then you want to investigate the right costs so you don't get caught out. So in conclusion, when it comes to data and analytics solutions that store files, you will typically want to use blob storage over storing files inside of a virtual machine. So file storage may sound like that it should store files like blob storage does, but in reality, that's there for legacy reasons. So a lot of older applications use protocols like SMB file shares to access data, whereas blob storage uses REST APIs, and not all legacy applications can be refactored to support using blob storage, the REST APIs. So in many cases, we won't be dealing with file storage and data and analytics, but maybe your customer or your company has legacy analytic applications that still use SMB shares to access data, so it's still worth knowing about it. Now, of course, onto HDFS. So if you want to learn about big data and big data applications, you need to understand that HDFS exists. HDFS is a distributed file system, which means that data is spread across many nodes. A node is basically a virtual machine for performance reasons. So think of a scenario. If you want to find sales data for a particular year, is it more efficient to scan one big file from start to finish to find that sales data? Or is it better to break that file up into 100 smaller files, spread it across multiple servers, and have each server scan those smaller files in parallel? Well, it's much faster to do the latter than it is to do the former. So Azure has two different HDFS offerings, Azure Data Lake Store Gen 1 and Azure Data Lake Store Gen 2. Gen 1 was really just pure HDFS, so it really only worked well with big data clusters. A lot of people said to us, hey, it's not easy accessing this data from my custom application. So for Gen 2, Microsoft merged the robust capabilities of blob storage. Remember I said that it's accessed programmatically with the HDFS capabilities of Gen 1. This basically means that you have a storage layer that can work with big data clusters, but it's also very friendly developers to integrate with as well, and that is Azure Data Lake Gen 2. One note about Gen 2 is that not all Azure services fully support Gen 2, but it is the roadmap, and it is basically the future that Gen 2 will be the standard moving forward. All right, so on to the next option, which is about consistency. So when it comes to cloud storage, you typically have two consistency models: strongly consistent and eventually consistent. There are other options in between that offer various trade-offs, but for now we're going to ignore them and just focus on these two consistency models. So what does this consistency mean? If something is eventually consistent, and if you're coming from AWS, S3 is eventually consistent, then it means that when someone updates an object or a file, and then someone else reads that file at the same time, the reader may not read the latest version of the file. So most of Azure storage is built around the strong consistency model, which means that when a file is written, the latest version can be read. So why does this matter? Well, eventual consistency works fine for data that is moving through your platform in a batch process, so like every minute or so, or even every hour or every day. However, if there is very fast moving data, such as in an IoT or a real-time sort of analytics solution, you may not actually be reading the latest version of the object that's being written. So that actually can be quite bad. The trade-off with strong consistency is the durability of the data, meaning there is less redundancy built into that storage platform using the stronger consistency models. So when thinking about your data platform, think about which consistency model is going to work best. But typically, fast-moving real-time IoT data, strong consistency. Data that needs to be durable but doesn't move fast, eventual consistency is okay. The final thing to consider is when to use object storage and when to use databases. So, also when to use SQL versus graph versus relational databases versus data warehouses, but we'll talk about more of that in the next video. But for now, let's think about when do we use a database and when do we use storage. So I see a lot of customers just going for a data warehouse and ignoring the data lake store. But it's important to know that each platform complements each other to build out your data estate. Data lake storage is typically much cheaper than database storage, so it makes sense for all of your data to go into your data lake store, and that will be your single source of truth, as we say, or the source of all your data. You can archive and you can compress old data and move it into cheaper storage, so it basically enables you to keep all of that data forever without having to worry too much about cleaning data. It's important because you never know the business value of that data may have sometime in the future. Databases, on the other hand, are much easier and sometimes faster to query, join data together, and to consume that data. So typically, data that holds business value gets moved from the data lake store into the database or data warehouse. Also, when it comes to real-time reporting, sometimes moving data to storage and then to a database is too slow. There can be like a delay of 5, 6, 7 minutes. So in this scenario, we store a copy of the data in the data lake store for historical analytics purposes, but we can also push data, say the last 400,000 rows or so, into our data warehouse for real-time reporting, or even directly into Power BI, and we can talk more about that later. All right, so that's enough talking. So let's jump into the console and take a look at how to provision this storage. So here we are in the Azure console, and the very first thing we're going to do is we're going to create a resource. So we click on this. Now there's a couple of different resources that we can create. If we just go down to where it says storage, we can click on storage. You can see we've got storage account, blob, file, table, queue. We've also got data lake store Gen 1. So again, this is the HDFS compliant, but only HDFS data store. For legacy reasons, there are a lot of different things that support Gen 1. There are some things that don't support Gen 2, but it's always a good idea now to actually create Gen 2. And you notice Gen 2 isn't in here. Well, where is it? Well, Microsoft have rolled it up under the storage account. This is where you go and pretty much create most of your storage. So you click on storage account, and you can see here that we have many different settings. So if you remember, we created our resource group. So we're going to go and put this in the resource group that we created. We're going to give it a name. Now, if we look under here, the name must be unique across all storage names in Azure. So it's a global namespace, and it must be 3 to 24 characters long and only contain lowercase letters and numbers. So what we're going to do here is Azure Data Guy storage. Actually, let's call this Data Lake Store Gen 2. Now I'm going to put it in my region. So we have performance. So this is whether you're using SSDs or not. What we're going to be, we'll just keep it standard for now. Your account kind, this is the sort of APIs here. We want to keep it version 2. This is the replication. So again, if you remember what we talked about when it came to consistency as well, different replication are going to give you different consistency models, but because we want this to have the strongest consistency, we're going to choose locally redundant storage. Now access tier, this is hot, which means that the data is being accessed frequently, but you can also have a cool tier here. And if we have a look at the tooltip, Cool tier is better for data that's infrequently accessed. So basically what it means is that you pay less to store it, but you pay more to retrieve it. On hot, you pay more to store it, but you pay less to retrieve it. So from a networking perspective, do we want to access this storage publicly, or do we want to have it private? I'm going to have public endpoint. From a security perspective, this is actually okay because you still need access keys and multi-factor authentication and to actually access the storage. So it's not like that it's out there for all the world to see. You still need to authenticate. Just take note of that. So a whole bunch of stuff here. So SSL, yes, we almost always want SSL. The reason you may not want that is maybe some legacy application doesn't support it, but in almost all scenarios we want to keep this enabled. So remember we talked about file shares. We don't want file shares typically for a data platform unless we need SMB shares. Data protection, so we're going to have soft delete, yes or no. And then here, this is what we want, is data lake store gen 2. We want to turn this on. So we want to actually have an HDFS storage account that also has all the capabilities of modern blob storage. And hierarchical namespace basically means that we have a folder-based way of browsing our data lake store, and we can use ACLs to control permissions, because in blob storage it's all about containers and objects, whereas from a big data perspective we want hierarchical namespaces, i.e. folders. Remember we talked about tagging. So in our scenario, what we're going to do here is our project is, let's just call this, we're going to make sure that we do our tags. Resource type we don't need. Owner is me. And then we're going to review and create. Now it's worth noting that you don't pay anything for this until you actually start putting data on it, which is a great value proposition of cloud storage. So our deployment is underway. This actually should deploy quite quickly. If it doesn't, we'll be back in a moment. Okay, that's now complete. Now if you do want an option that's on free tier, again, remember you don't pay for the storage until you actually start using it, like putting stuff on it. But if you do want an option that's on the free tier, then you do have this 5 gigabytes of blob storage here as well, which is locally redundant storage, hot. So if you create that, now let me just test to see if we can actually use blob storage. Let me just type in something there. Yes, you can also use data lake store on the free tier. Okay, so our deployment is done. Let's go have a look. So this is our storage account. So this is where we manage what is a storage account. So if you're from AWS, it's like a bucket, although kind of not. Anyway, so you've got all these different settings here. Notice we've got this Storage Explorer, which is a preview feature, but we've got Storage Explorer here. This is so we can browse our storage. There's a whole bunch of other things here as well, but from a data and analytics perspective, the main thing that we're going to be interested in is the Storage Explorer and the containers, if I can find them. Here we go, containers. See, under data lake storage containers. So we're going to click here, and what we're going to do is we're going to create 3 containers. And you can see the access level here. We want to keep these private. So we're going to have a raw container, and then what we're going to do is we're going to have a staging container, and then a curated container, and then a lab container. Now this is a convention. Many different companies and conventions are similar to this. And the idea is that In the raw bucket or the raw container, this is where you just put all of your data. So whether it's real-time data or whether it's streaming data, whether it's streaming data or whether it's batch data, whether it's JSON, text, whatever, you just put it all into raw. And this basically sort of becomes your archive, for lack of a better word, of your enterprise data. Then what you do is you clean data that's got business value. So you take everything from raw, you clean it, you remove columns that aren't of any use, and you put it into staging. Different companies call this different things, but effectively staging is where you have your data ready for your analysts and analytics data scientists to actually begin working on it. And then what they will do is that they will generate insights and predictions and things like that from this data, and then move that into curated. And then of course lab is for experimental purposes. So then how do we secure this? So as you notice, it's private, but typically no one really except the owner of the data lake should have access under raw. So what you can do is you can click on this and then you can go change access level. And you see that you've got private, which is no anonymous access, and then you can have anonymous read access, and then also anonymous read access for containers and blobs, so files, folders and files. But that's not going to fit our purposes. We want to actually be able to lock these things down by permission. So let's have a look at how we do that. Okay, to manage permissions, what we need to do is get the Storage Explorer. Now there is Storage Explorer here, which allows us to browse through our data lake store, but we can't manage access from here. That feature will be coming. So what we want to do is use the Azure Storage Explorer. So if you go to Google, you type in Azure Storage Explorer, you can choose your operating system. It supports Mac, Linux, etc. Download for Windows. I already have it installed. Once it's installed, and then once you load it, it'll look like this. Okay, once we open up Storage Explorer, it'll look something like this. If you get a notification to install to the latest version, then you're going to want to do that. And then you may have no accounts here. And if you don't have any accounts in here, you can just add in your account into your Azure subscription, apply, and then once your account is associated with your Azure subscription, you'll be able to see your resources here. So we can go into where our subscription is, we go storage accounts, and then we can actually find our storage account here. Okay, so under storage accounts, we can see our storage account name. Then we want to have a look under blob containers. And here, once we right click on one of our containers, manage access, this is what we want to do. We want to manage access. And then in here, this is how we can control our ACLs. So you have read, write, and execute. So effectively in a corporate environment, production environment, or a real environment, what you want to do is you want to make sure that under your raw container, only the owner of the data lake has access to that. There will be other components that write into the data lake, and they should only have write access, but we'll show you how to configure those when we get to that. So for example, Data Factory and Stream Analytics will need write access into the folder. Then of course, you may be thinking, oh, well, what to do next? So you can create new folders in here, and typically the way that you do it is you structure your folders out by raw, and then you'll have your source system that is coming from. So for example, let's say that we could just even have real time, and then under real time I can have a new folder, and maybe this is all my Singapore real-time analytics. How you're going to break it up is going to will make sense based on how your use case or your organization is structured, but it's generally source, subsource system, And then what happens underneath this is that it gets broken down by time, but we do that automatically. So likewise here, we could have raw, and then we could have batch, and then under here we might also have the region that we're in. Why not just all put it into a Singapore folder or a regional folder, you may say? Well, because it's going to be different file types. Real-time is typically going to be JSON, and then batch data is probably going to be CSV or some sort of column store file, and you don't want to have different file types in a folder, which is why you break it down by source and then subsource system. The reason for that is that it becomes much easier to use other tools in Azure like Data Factory or even Spark and so forth if everything in the one folder is the same file type and also the same schema. So maybe we have 3 different databases, for example, that's actually writing into the Singapore folder. We probably, let's say that the schema for one of my databases is DBO, and then the schema for another one, or another schema in my database is, let's just call this, maybe this is my finance operations or something like that. You want to break it down like this. Alright, then staging. Typically what you'll have under staging is that staging will match what you have under raw, because what happens is that it's almost a match. It's a one-to-one match of the data in raw. It's just clean, which means that all the columns that you don't need are gone. It's not in JSON anymore. It's in Parquet or CSV. And then all of the null values and so forth are gone. Then under created, your data scientists will typically structure data in here on a project by project basis. So with the raw folder, only a data lake owner will want to have permission over that. Let's have a look at staging. Let's say we've got our staging folder, and then we have batch, and then we have Singapore, and then under Singapore we have DBO. Everybody that has permission for this schema should also basically have permission to this folder. So how we do that is we can do access on the folder level here. So we can choose DBO, and then we can go manage access. And then again, we can find our user group in Azure Active Directory, and we can give them the appropriate access here. Now this is different from just pure blob storage, because blob storage, it's trickier to set up permissions on these containers like this, and this is where the ACLs from HDFS come into play. So it makes it quite powerful in order to be able to really set your permissions on your data store there. Okay, so we've covered how we go through the console, and then we go and set up our data lake. What if we want to use infrastructure as code to build this? Well, we can do that. Maybe I'll cover that in another topic towards the end on how to automate a lot of this through either templates or infrastructure as code. But for now, that's how we go and provision it. So just another point here, encryption is on at rest by default. So the data inside of this is encrypted. If you do put it behind or want to protect it behind a virtual network, then you can fine-grain choose which networks or VNets and IP addresses that want to have access to this storage account. So you can lock it down by IP address, and then also you can attach it to a virtual network here. Also note that you can allow trusted Microsoft servers to access the storage account, which means that Stream Analytics and other Azure services will be able to write to it without having to know their IP address. That's pretty much it for this video. So in this video, we've got our storage set up, we've got our different containers set up, and then what we'll do in the next video is we'll go through and have a look at some databases. All right, that's it for now. Bye.